'cause I don't give a fuck what you say. Yeah, I'ma do shit my way.
Throughout history, mankind has demonstrated an uncanny ability to overcome obstacles. Be it the wheel's transformative effect on travel, agriculture's role in urbanization, or the printing press's spread of knowledge. We've continually pushed the boundaries of what's possible. Space travel, once a monumental challenge, now points to a new frontier. How can we make accessing the cosmos cost-effective? The fuel-based methods we rely on could soon prove insufficient. In our reliance on fuel, we find a gap in our knowledge, a hurdle we must clear. Could the answer lie in a space elevator? Let's explore. To understand what a space elevator is, we must first grasp the real challenges of getting to space. It all starts with gravity. Earth's gravitational pull holds everything to the planet, and to overcome this force, conventional rockets must travel at a speed of around 25,000 miles per hour. This requirement leads to a major challenge: fuel. To reach such speeds, rockets consume vast quantities of fuel. Approximately 90% of a rocket's weight is fuel, making space travel incredibly expensive and resource-intensive. Conventional rockets are essentially controlled explosions, propelling spacecraft at speeds necessary to break free from our planet's gravitational pull. This means there's a significant risk of catastrophic failure at various stages of launch. Tiny miscalculations or malfunctions can lead to a disaster, as history has sadly shown. Moreover, the environmental impact of burning such massive amounts of fuel contributes to pollution and climate change. A space elevator could solve these issues. The idea of a space elevator presents a potentially safer, cleaner, and more controlled method of reaching the cosmos, opening doors to innovation and exploration. A space elevator would be the single largest and most expensive structure ever built by humans. But is it worth it? It all comes down to costs. Today, the current price tag to get to space is $20,000 per kilo. That's roughly $1.5 million for the average person, or $32 million for your car. A space elevator would drastically reduce that cost, up to 100-fold, bringing the cost down to $200 per kilo. If we consider the cost to build a space elevator at roughly $80 billion, the savings would start to outweigh the investment after sending a combined weight equivalent to just 2 international space stations. What would a space elevator look like in real life? There are 4 major components: the tether, anchor, counterweight, and the climber. So now that we know what it could look like, how would it work? The space elevator remains upright due to its counterweight rotating at high speeds above the Earth. Let's break it down. Think of swinging a rope with a weight at the end in a circle. If you swing it fast enough, the rope stretches out and becomes straight, revolving around your hand. This straightening is the result of an effect known as centrifugal force, pulling the weight away from your hand. Now, imagine that on a grand scale with the space elevator. The Earth's rotation generates the same centrifugal force, pulling the space elevator's counterweight away from the Earth's surface. This outward pull keeps the tether taut, and with the anchor securely fastened to Earth, it creates a pathway for climbers to ascend and descend vertically. That's the essential idea behind a space elevator. Can we actually build a space elevator? The physics and engineering suggest that it is possible, and once operational, economically superior to any other current form of getting to space. One issue lies with the tether. Currently, we do not have a material strong enough. The material needed for the tether would need to be 23,000 times stronger than steel. One possible solution are carbon nanotubes. However, the mass production would be a hurdle in and of itself. Something else to solve is, do we build the tether in space and lower it down to Earth, or do we build it on Earth and raise it to space? Another issue is, how do we power the climber? Do we build a power plant on the climber? Do we use powerful lasers on Earth? Addressing these questions is fundamental to realizing the concept of a space elevator. Collaborative efforts between scientists, engineers, and policymakers will be crucial in overcoming these obstacles, paving the way for a more accessible and economical path to space exploration. The risks involved in a single mistake could be catastrophic. If we fail to create a strong enough material for the tether, the climber could fall back to Earth. The counterweight would shoot off into space, and the tether itself would wrap around the Earth, destroying anything in its path and making future space travel more difficult. If we build the space elevator, it must be done correctly the first time. Because of this, some experts suggest building the first one on the Moon. The Moon has much less gravity than Earth, and the consequences of not getting something right would be much less severe. Wherever we decide to build it, a space elevator could be the first step to becoming a spacefaring civilization. While hurdles exist in constructing a space elevator, overcoming them would lead to a revolution in space travel, reducing costs 100-fold, broadening accessibility, and paving the way for easy replication and sustainable exploration. Once up and running, would you ride the space elevator? If so, what would your destination be? A luxury resort? A spacecraft headed to Mars or another planet? Let me know in the comment section. If you enjoyed this, hit the like button, and if you're a curious person, consider subscribing. Until next time, stay curious.